So this one here is from the 2013 AP exam. Okay, this is given, we're given again a graph, this time the graph of the derivative. So in the past ones we've been given a function of the derivative, we've been given a table of the derivative. This one here now is a graph of the derivative. And we're told the areas of those area pieces in here, so that is going to be useful. So this is graph of f prime. It's a twice differentiable function, so it's continuous, and its derivative is continuous as well. We can kind of tell that because it's smooth. And it's on a closed interval. It's got horizontal tangents at 1, 3, and 5. Okay, so 1, 3, and 5. Okay, I'm just going to draw those in. We know that the slope is the second derivative is equal to 0. And the areas and regions are given, and the function is defined for all real variables and numbers, and we know that there's a starting point at 8. If we start at 8, we know that the f value is 4. So we can set up our integral starting at x is 8, the y is 4. So find the values where it has a local minimum. When we want to talk about local minimums, we want to talk about where it hits 0 and goes through 0. Okay, so here we have a 0, here we have a 0, and here we have 0, although this one we probably can consider that it's probably not going to be a min or max because it's just bouncing off there. So I'm just going to do my slope chart here. F prime, okay, at looks like 1. We know it's positive, 0 positive, so it goes up across like that. Okay, so this is a slide, okay, through that point. At x is 2, 3, 4, at x is 4, we know we have another 0 here. It's going to go like that, and it's going to go from positive slope on this side to negative slope on this side. So we know it's going down. Okay, so it's negative there. And the last point here, looks like it's 6. We have a 0 point here, okay, and it's negative on the left, positive on the right. So it's going to go down and then up. Okay, so that's what our slope chart looks like. So where is the local minimum? Okay, we don't have a local minimum here because it's a slide. We have a local minimum here at x equals 6. So we can justify this with our slope chart. So this happens at x equals 6. So to determine absolute minimum, well, we know this is a continuous function, so we don't have like breaks and kinks into it. So and non-differentiable points. So all we have to worry about now for absolute minimum is the endpoints and this local minimum. So I need to first of all figure out, this is my candidates test. Okay. So we have a candidates test. We need to do, the endpoint is 0, I think, 0, 8, and we need to have the 6 as a potential candidate. So we need to calculate f of 0, and we're going to do it this way. We know it starts at 8, and we have a y value of 4, and my integral is going to look like this, starting at 8 to x of f of t dt. Do we call that f or f prime? We call that f prime. Okay, that's what we're looking for. And I'm going to start at 8, which means that I have to go backwards this way to integrate. Okay, so there's a bit of a problem in that if I go backwards, the areas above are negative and the areas below are positive, because instead of integrating left to right, we're integrating left to right to left. Okay, so left to right, the areas above are positive, the areas below are negative. Right to left, the areas above are negative, and the areas below are positive. Okay, so that's important. Maybe I'll just draw a quick diagram here. Okay, so if I have positive area and negative area, okay, in this direction, that's going to be positive and that's going to be negative. Okay, if I talk about integrating in this direction, okay, which I'll draw the same graph, that will be positive area, that's negative area. That's what normally we would expect. Okay, but this is not the case. So I'm just going to start with the easy one because we're starting at 8. So I know I have no displacement. So maybe I'm going to do that as my first one instead of f of 0. Okay, so I'm going to go f of 8 is equal to 4 plus integral from 8 to 8. Okay, that's going to be 0. 4 plus 0 is 0. Okay, so that, and we know the y coordinate's 4. So that is going to be my y coordinate at f of 8. So I'm just going to move that over here to get that a little bit out of the way. Now I want to calculate 0 and 6. So to do that, I need to calculate all the areas. So going from right to left is going to be -7, +3, that's -4, -6, so it's -10, and -2, so that's -12. Okay, so my displacement then is going to be -12. So from 0 to 8 to 0 of f prime t dt, my displacement was -12. Okay, so my y value is going to be -8. Then I need to do the same thing for f of 6. Okay, I'm going to integrate from 8 backwards to 6 of f prime t dt, looking at this area from 8 to 6. I think that's 6 there. So it's, the area is above, so it's -7 displacement. Okay, so then we're going to start at 4 and go backwards, and we're going to end up with -3 displacement. So there's my -3. So to work out, I forgot what the question was now. The absolute minimum on that interval is going to be at that point there. So that's my absolute minimum. Okay.